Hello again. This is Math 0465 coming to you from the College of DuPage, and this is a lecture aligned with section 1.3 in your text, which is entitled Hello, my name is Graphing Points. As always, please be attentive while watching this video. We're going to begin talking about the Cartesian coordinate system, and it's composed of two number lines called axes that intersect at a right angle. The horizontal line is usually called the x-axis, and the vertical line is usually called the y-axis. The values on the number line increase from left to right on the x-axis and from bottom to top on the y-axis. The point of their intersection is called the origin. The axes divide the plane into four regions that are called quadrants. This is called quadrant 1, quadrant 2, quadrant 3, quadrant 4, and they're labeled with Roman numerals starting up here and going counterclockwise. Every point on the coordinate system has a position that is described by an ordered pair, which functions like an address. If we're using the x and y axis, the ordered pairs are of the form parentheses x comma y, where x represents the x coordinate and y represents the y coordinate. The x coordinate describes movement from the origin along the horizontal axis, and the y coordinate describes movement from that position in the vertical direction. Positive numbers indicate movement right for x or up for y, and negative numbers indicate movement left for x or down for y. The origin's position is described by the ordered pair 0, 0. So for example, 2, 3 is an ordered pair that indicates a point in the first quadrant. 2, 3, up here. When there is a context for the ordered pair, it's a good idea to label the axis with letters that have some meaning for the situation, sometimes like H for height, but otherwise we use X and Y generically used. And the X and Y that we're talking about are the letters that are used to label the axes are examples of things called variables. A variable is a letter used to represent an unknown quantity that can take on various values. For example, in the ordered pair x comma y, x and y are letters that represent the numbers that can change. So here is an example then I'd like for you to do is to plot the point -3, 4. So take your time and give it a go. Let's see how you did. So here you start at 0, 0. The x is -3, so we go 3 units this way. And the y is 4, so we go up 4 units. So this is the ordered pair -3, 4. I'm going to ask you for each point on the graph, shown here to be point A, point B, and point C, state the ordered pair represented by that point and where it's located. So please give it a go. Let's see how you did. So A is 5 units to the left and 2 units up. It's in quadrant 2. B is 0 units left or right, but down 4. And so it's on the y-axis. And C is 5 units from the origin to the right, but nothing up and down, so it is on the x-axis. So to give you a process to plot an ordered pair, start at the origin, the intersection of the two axes. Move horizontally using the first number of the pair. Positive numbers indicate right, negative numbers indicate left. From the ending position in step 2, move vertically using the second number in the pair. Positive numbers indicate up, negative numbers indicate down. And draw a point at the location. So for example, to draw 5 minus 2, you go over 5 and down 2. To determine the coordinate of a point, you start at the origin, the intersection of the two axes, and determine a path to get to from the origin to that point. The number of horizontal units becomes the x-coordinate, and the number of vertical units becomes the y-coordinate. Be careful to include negative signs in the coordinates if it is necessary to move left or down to get to the point. So to move from the origin to this point, which is up here, we move one left. That was -1, 4. So the ordered pair here is -1, 4. So to read the coordinates of a point on the graph, determine the movement needed to get from the origin to the point, and think of horizontal movement and then vertical movement for the x and then the y. Now, here in problem 4, I'm asking you to take these letters, use those to indicate where the points are, and tell me what axes these are in. And so we're talking about 3, 4, 5, comma, 1.7, 2, comma, -4, -5 halves, comma, -4, 0, 1, and -3, 0. So plot them and tell me what the axis is. So pause, do the problem, and then we'll see how you do. How you did. Okay, so 3 and 4, 3, 4, and 5, comma, 1.7 are both in quadrant 1. In quadrant 3 is -5 halves, -4. In quadrant 4 is 2, -4. And 0, 1 is on the x-axis, and -3, 0, 0, 1 is on the y-axis, and -3, 0 is on the x-axis. Let's do this again, but this time I'm giving you the point and asking you to tell me what are the coordinates of the point and what is the axis. So again, we're doing this in the reverse order to what we did before. So please pause the video, give it a go, and then we'll see how you did. Okay, so 2, 3 is in the first quadrant, -4, 1 is in the second quadrant, 1 minus 5 is in the fourth quadrant, and -2, 0 is on the x-axis. Now, a line graph is a series of connected ordered pair points, and often they display what's happening over time. So if you have a time in hours, and here you have the concentration of the medicine, and they can use liquid or they can use tablets. Now, tablets metabolize slower, but also don't because other things are happening, and so you don't get quite the boost and the absorption so fast. But the adult liquid goes up, and then it decreases. The extra strength tablets, you have to take them, you have to digest them into the bloodstream, and then you have it like this. So this represents what's happening with acetaminosin, the active ingredient in Tylenol, based on time. And there are two line graphs, one for the liquid medication, one for this. So what you want to do is write ordered pairs for the point indicated by the arrow right there and interpret it. And talk about what happens with the shape of the graph. And when the two formulations reach the same concentration, when is that? And so this is what you want to do. Please pause the video, give it a go, and we'll compare notes. Let's see how you did. Okay, this point right here is 2, and it is 12, and that was for the tablet. So after 2 hours, the concentration has dropped to 12 micrograms per milliliter. In B, what this shows is the concentration drops to a low level and is no longer effective, and that's why you need to get a second dose to maintain the level of medication. And when do the two have the same concentration? It's a little bit hard to tell. It's somewhere between these two, but I guess I would say between 5 and 6 hours is when that happens. Okay, so to make a line graph, you determine the variables that will be graphed and the values to be graphed for each variable. Draw and label the axis. Put the values to draw in a chart, and label tick marks showing a consistent increment for each axis. Plot the points and connect them, and give the graph a title. So here's an example of Number of days since the outbreak down here, and the number of sick students. And you see it rises up, but then it falls down. Now here is a line graph that represents mortgage rates for 30-year fixed mortgages. Now if you look at this, you can see that they start at 4.6 and go up to 5.1, and they're showing this. So the question is, what impression does the current graph give you about the trends in mortgage over those weeks? And then we ask you to redraw it if you don't have this axis beginning here, but you have all of these other numbers. And what impression does that give? So please give this a go, and we'll go from there. Let's see how you did. Well, here was what you have, and it appears that the mortgage rates drop dramatically, but the scale is misleading. And if you drew the other scale starting at 0 here, you see that they really don't change much at all. It really didn't change very much. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. God bless you all, and more math soon.